So today we're going to go back and look at chapter 6, the actual chapter 6. We're past the mid-chapter point. So we're going to go ahead and go to 6.7, day 1. It's called the Roots of a Quadratic. So if you remember what we did it back in chapter 6, we did a lot of graphing quadratics, and we're going to be looking at that again a little bit. So we're going to be looking at how do you find roots of a quadratic equation. And we'll talk about what does that even mean? What is a root? So here we go. The definition, root of a polynomial. The roots of a polynomial is where the graph crosses the x-axis. This is also called a zero of the polynomial. So it's just where the graph crosses the x-axis. There's an example down here, as you can see. This is a parabola or quadratic equation here. Remember we see like the happy face, sad face? We're going to go back to that. Remember we talked about the bottom part here being a minimum, and it's a vertex. That's all the same stuff. The new thing we're talking about is a root. So this is where it crosses the x-axis. So here's the x-axis, and wherever it crosses is called a root. So right there is a root. Here's a root. They also call them the zeros. So you can also call this a zero. Both of them. Whoops. Change that. A zero. So we're going to be finding out where these graphs cross the x-axis. And that will become a little bit more important later when we do maybe some word problems. But we don't have to graph and try to find where it actually crosses the x-axis. So we can find the roots without graphing. We first do this by setting the y value equal to 0. And then, most likely, we have to factor. So think about this, like whenever you look at this graph here, that's over here, this is the y-axis. And so what we're going to be looking at is we're looking at the y value, right? This is like the positive y value. We're looking at the y value going down and reaching 0. We're trying to find what x value this is and what x value this is. But we do know at this point, in both cases, that y is 0. And in this one, y is also 0. So once we know that we have the y value to be 0, then we can talk about factoring and figure out where this happens. One of the biggest theorems we have to talk about, though, is the zero product theorem, which says for all a and b, so if you have two numbers, a and b, doesn't matter what they are, if you have a times b equals 0, right? If you have two numbers being multiplied to give you 0, what does that mean? So let me give you an example. Right? If I have 5 times something equals 0, right? What does that other one have to be? It absolutely has to be the number 0. The only way you can take a number and multiply it by another number and get 0 is only if one of these is 0, right? If I said 0 times any number, what's that give you? All the time it will be 0. So if I don't know the two numbers at all I can really say about it is I know that one of the two, or even both, but at least one of them has to be equal to 0. That's a pretty big concept that we're going to be using today. So if you have a times b equals 0, we know that either a is equal to 0 or b is 0. One of them has to be true in order for this to be a true statement. So when we do these problems, to use this theorem and find the zeros, we have to first make one side of the equation. So we're going to have an equation like this. We're going to make one side of the equation equal to 0. And again, if there's a y in there, if there's a y in the equation, we have to set that equal to 0 first, and then we'll move each term to one side. So all the terms that we're given, we're going to have all on one side, and the other side will be equal to 0, so we have something like this. Then we can apply this rule. And again, if there's a y in there, we know the y value is going to be 0, so we're going to change it to 0. So let's try it. So example 1 says, find the roots of the following quadratics by factoring. So what do we do first? I'm going to change the y value to 0. Change it to 0. Then we have 0 equals x squared plus 10x plus 24. All right, that's pretty easy. Now we have to figure out how do we factor this. It's already 0 on one side, so I'll keep it there. How do we factor this? This is the shortcut method. So I'm going to go 2 sets of parentheses. We're multiplying to 24, adding to 10. That should be 6 times 4, 6 plus 4. And if you remember, we have shortcut means we just put plus 6 plus 4, and then x and x. So this is where I'm going to go back to that zero product theorem that says if you have something times multiplication here, something else, equaling 0, then one of these has to be equal to 0, either the first thing or the second thing. So to answer this, we know that x can equal, this is kind of branches off the two answers, right? X can equal, what would make this 0? The number that you'd put in there would be -6. This is kind of it's a lot like the restrictions that we did earlier. Whatever makes that 0, so that would be -6. What makes this one 0? That would be -4. So these are the 2 points that if I were to graph it, they would cross the x-axis. Right? So if I just drew a little quick graph, and it looked something like, I had to point the points here. This would be like -4 on the x-axis. This would be like -6. For instance, it would go through both of those points like this. Okay, let's try another one. This one is a little bit different because things are kind of moved around, but it's really no different. We always change this to 0 because we want to know where does it cross the x-axis. So this would be 0 plus 4x plus 21 equals x squared. But you don't really have to put 0 here. It's not going to make a difference. What I am going to do is I'm going to move these terms on the right to the other side. I'm going to move these ones over. And so why am I going to do that instead of moving the x squared? It's because we really want the x squared to be positive. When we do our factoring, we need to have this over here to be a positive number. In this case, it was 1. So I'm going to subtract 4x, and I'm going to subtract 21. Let's go back here. So I'm going to bring over 4x, and I'm also going to subtract 21. I'm going to do it at the same time. Why not? Minus 4x minus 21. So we get x squared. These cannot be combined, just minus 4x minus 21 equals, those go away, 0. So now we're set up to do factoring. Again, this is shortcut, so we'll do 2 sets of parentheses. We're going to multiply to -21. I'll put it over here. Add to -4. Whoops, that's a plus. So what would that be? Looks like it would be 7 times 3. And one of these has to be negative, which would be -7 to get that -4 here. So we have x minus 7, x plus 3, and then we have our 2 answers. Remember, if we have one thing multiplied by something else to give you 0, what makes both of these 0? One answer would be 7. That makes that 0. The other answer would be a -3. And those are your 2 answers. So that's both with shortcut, but you could have any types of factoring. Right now, we've just been dealing with shortcut. Part C, again, let's just change this to 0. And I'm going to go a little bit faster here. I'm going to add 10 to both sides, since I see x squared and 7x is already over here. So we have x squared plus 7x plus 10 equals 0. Factor this. Multiplying to 10, adding to 7. Should be hopefully really easy. How do you get 10? 5 times 2. 5 plus 2. So x plus 5, x plus 2. What would make these 0? That would be -5 and x equals -2. So if you're pretty good at factoring, these should not take that long. And again, all we've been doing is the shortcut method. All right, one more here. We're going to make this 0. And I don't know if you noticed, but this is a -x squared. I don't like that, so I'm going to move that one over. So let's add x squared. And I have to have this in the right order. If you notice over here, we have x squared and x and then just a number. I got to have that over here. So I'm going to put x squared first. I'm going to move the -x to the front here. And then I'll move the -30 to the end. This side cancels out. We just have 0. Factor again, shortcut again. Multiplying to -30, adding to -1. Let's see, what would that be? 5 and 6? And we got to get -1, so -6. So we have x plus 5, x minus 6. Values that would make them 0 would be -5 and x equals 6. And those are the zeros. Again, this would probably be a fairly wide one. -5 would be out here, 6 would be out here on the x-axis, right? And so these would be the places that you would cross the x-axis, like this. Oh boy. Something like that. It's hard to freehand. So there is a huddle for 2 problems, and then we're going to go ahead and move forward. So you can try those. There is some more factor we're going to do together. And then we'll get to some of the word problems. Our example 2, we're just practicing some more. Set this equal to 0. How do you factor this? Looks like it's going to be a GCF. So let's take out a 6x. And then we'd be left with x plus 2. All right, well, we still have 2 things being multiplied together like this. And so we have to think about, well, what would make this one 0, 6x? 6 times what gives you 0? That would have to be 0. We did that before with restrictions. And then this one, to make that 0, would be -2. All right, part B. This one does not have a y in it, so we just have to make one side equal to 0. And I'm going to move this one on the left over to the right, so that way we get a 0 over here. So we add those together, it goes away, you get 0. Here we'll write this in the right order, 2x squared plus 22x plus 48. And then we'll factor it. This has a GCF, we'll take out a 2. X squared plus 11x plus 24. And then we can factor this, multiply to 24, add to 11. Another shortcut method, 24, 11. Looks like that's going to be, we have 6 and 4. Nope. We have 8 and 3. That should work. Both positive. So x plus 8, x plus 3. And then the 2 values that work here. We don't have to worry about the 2 here. This is 2 times anything. If one of these would be 0, then it would wipe out the 2 as well. So here would give you a -8 and a -3. There's your answers. Part C, looks like you have another thing that looks like a GCF, but hold on, I don't think there is a GCF here. Nothing goes into 9 and 64. Let's first make this 0. So how do we factor this? If we have 2 terms with subtraction, it looks like this is going to be difference of squares. And it will be. That will work. So we would factor this. This would give you 3x and 3x. That's how you get your 9x squared. How do you get 64? That would be 8 and 8, plus minus. Oh, but how do you make these 0? That makes it a little bit more tough. If you don't know how to do it, again, you can bring this down. And we can set it equal to 0. You can do it to both of them. And solve each one individually. And that will give you the answer. Now, when you do this, you subtract 8 and you divide by 3, you'll probably get a fraction or a decimal. I usually keep them as a fraction answer. 0 minus 8 is -8. divide by 3. Looks like we're going to have negative 8 over 3 as an answer. And if we do this one, not really any different. Add 8. We divide by 3. We're going to get x equals 8 positive 8 over 3. And those are your two answers. All right, part D. Let's plug in 0 here. And I will also bring over the 4x squared. Add that to the other side. This goes away. We get 0 equals 4x squared minus 16. There's a GCF here that we can take out. I'll take out a 4. Divide everything by 4. You get x squared minus 4. And then we will factor this. This is difference of squares, clearly. They're both perfect squares. It would be x minus 2, x plus 2. And then our two zeros would be x equals 2 or x equals negative 2. So that would be where it crosses the x-axis. All right, we have two hard ones left. We're going to do the hard method, the AC method. So if we change this to 0, and if you look at this one does not have a GCF, so we got to do the long method. So how do you do long method? Got to label ABC and go from there. I'm going to go ahead and go pretty fast through this one because I'm going to go ahead and then do the word problems. I think that's what we have left after another huddle. There's 2 word problems to do. So I want to focus more on those. So we're going to do A times C, in this case is negative 6. And we're going to add the B value, which is 5. So it looks like we're going to do 2 and 3. Nope, we can't do 2 and 3. That won't work. Maybe 6 and 1. 6 times 1. This would be 6 plus 1. We need a positive 5, so we'll make the 1 negative. And you remember when we do the long method, we have to split this into 2 different answers. So we have 0 equals 2x squared plus 6x minus 1x minus 3. And then we group. First one, you can take out a 2x, get an x plus 3. Second one, you can take out a negative 1, also gives you an x plus 3. All right, so we have 2x minus 1 and an x plus 3. Again, if you don't know how to get this one, you can solve that for x by setting it equal to 0. This one might be a little bit more obvious. You can get negative 3 here. If you don't know how to do this one, go ahead and set it equal to 0 and solve by adding 1 and dividing by 2. Although we've seen this before, we get 1/2. That is a 2. There we go. 1/2. 1/2 or negative 3. All right, last one here. We, again, don't have a GCF. We're going to set that equal to 0. I'm going to go ahead and label ABC and do it that way on the side. A times C is negative 24, and we're adding to get 5. That's going to be 8 and 3. 8 plus 3. But then 3 has got to be negative. So let's rewrite this. 6x squared plus 8x minus 3x minus 4 equals 0. Then we'll group. This one you can take out a 2x. Leave you with 3x plus 4. This one you can take out a negative 1 again. 3x plus 4. All right, so we have a 2x minus 1, 3x plus 4. And again, you'd probably have to solve both of these to see if you can figure it out. This one's going to be, you'd have to add 1 to both sides and divide. So this is a 1/2. It's the same thing we had over on this side. This one, I'll solve it real quick. 3x plus 4 equals 0. So you have to minus 4. And then divide by 3. So x equals negative 4 over 3. So they're not always nice whole numbers. It could be fractions, decimals. That's fine. But that's where they cross the x-axis. Okay, so let's go ahead and you can finish up the team huddle number 2, and we're going to finish this up by doing some word problems. So where does this really apply? Most of the time, it's for any type of projectile. If you were to take, say, a baseball, and you were to throw it in the air, right? Throw it to your friend or whatever. Every time you throw a ball in the air, the projectile usually looks something like this. It goes up, and then it comes down. And so what this looks like almost every time, no matter how you throw something in the air, because of gravity that brings it back down, it always looks like our little sad face. And so like this parabola that we have here is always shown by throwing something in the air or shooting like a rocket into the air, which is what we're going to talk about here. Every single time you do something like that, a projectile that goes up into the air, it always goes up at some point, slows down, reaches a maximum point, and then comes back down. So all of these are described by sad faces. I'm going to show you an example by reading through this problem, and we'll draw a little picture. So 3, suppose a rocket has been shot into the air. The height h in feet after t seconds that it is launched is given by the equation h of t, remember that's how you read this, equals negative 16t squared plus 128t. Okay, so let's just pretend that we have a rocket. I'm going to go ahead and draw like the ground here, right? We're going to pretend the ground is like the x-axis, right? And then we're going to pretend that we have a rocket over here. So here's the rocket. Don't make fun of me. And what's going to happen is it's going to get shot into the air at some point, and then it's going to come back down and hit the ground. So basically, if you look at this as like an x and y axis, so like we could pretend that this is like a y axis here. Just like draw a y axis going down. What we're going to find, even though you could probably extend these, what we're going to find is basically where the zeros are, right? Because if it hits the x-axis, we're going to call this the ground, but it's also those zeros or the roots. So let's go ahead and, now that we have our little picture, we can answer the question, how high is the rocket off the ground before it is launched into the air? So what we're doing here is basically we're going to say like 3, 2, 1, blast off, and the rocket's going to go into the air. When that happens, you're basically taking like a stopwatch and timing it and seeing, how long is it going to take for it to go up into the air and then come back down and hit the ground. So if we're looking at, how high the rocket is off the ground before it's even launched, that means we're looking at a time of 0. So before we even like start the timer and let it go up into the air, we're at a time of 0. So this means time is 0. Time is 0. So what we're going to do is we're going to look at this side over here and say, okay, we know t is seconds, and h of t is your height. So if we know the time is 0, I'm going to plug in 0 for the t's here. Oh, also this one over here. So we're going to do h of 0 equals negative 16 times 0 squared plus 128 times 0. This will be how far off the ground the rocket is. And if you evaluate this, you multiply these together, you get 0. 0 squared is 0 times 16 is still 0. The whole thing is going to be 0. So basically, it's just saying that the rocket is on the ground at the time before you shoot it up into the air. Sometimes they could be like on a platform or just off the ground, but we're saying here this value is 0. All right. At what time does the rocket hit the ground? So now we're looking at an h value. Now we're trying to find the height. What's the height when it hits the ground? Well, we know originally it's going to be, the height is going to be 0 here. And then as we increase the time, it eventually comes back down and hits the ground again. So the height here would be 0. So we're going to say, I should back that up a little bit. When h is 0, so when it comes up, it comes back down, it hits the ground. At what time is that? That's what we're going to find out. What time is that? So we're going to fill in this equation. We're going to fill in h of t and change it to 0. That's your height. So you have 0 equals negative 16t squared plus 128t. So we're solving for t. So how would you do that? Well, we have to use factoring. So there is a GCF between negative 16 and 128. I'm going to factor out a negative for 1. But 16 actually goes into 128. And we can also take out a t. And then just divide the 128 divided by negative 16. And that's going to give you an 8. So we would have t, divide this by a negative, so it'd be minus 8. Just change this real quick. So now we have two options here as to when the rocket hits the ground. If you see this multiplication between here, we have one option here and one option here. This one is obviously, if you plug in 0 here, a time of 0, that would make this 0. But we already knew that. We knew that the rocket was on the ground. So the first 0 we have is at 0. The second one would be whatever makes this one 0, which would be a time of 8 seconds. And so that's the point we're looking at here, where your time is 8. So we already knew about this one. We're not going to use that one. We're going to cross that one off and say it would be 8 seconds. All right, we have one more to do. I would really like to wrap this up because I know it's getting kind of long. But it's a very similar concept. And now we have a rocket that is being launched directly upward at 64 feet per second. That's feet per second is the unit here. From a platform, so now it's above ground somewhere. The equation representing the situation is h of t equals negative 16t squared plus 64t plus 80. Okay. How high off the ground is a platform? So now we're going to have some kind of platform that's on, right? And then we have a rocket up here. It's going to be shooting off the bottom here. We want to know how tall this is. So we want to know, we don't know h, right? But we do know that before it actually gets shot up into the air and comes back down, that it's going to be 0 seconds. T equals 0. So let's plug that in. We'll have h of 0. It's just like the last problem. Negative 16 times 0 squared plus 64 times 0 plus 80. So if we were to evaluate this at 0 seconds, this becomes 0. This becomes 0. 0 plus 80. So it looks like the platform would be 80 feet. So I'll just fill that in here. 80. All right, part B. How many seconds does it take the rocket to hit the ground? So if we shoot it up into the air and then we come back down, we'll see how long does it take to hit the ground. So we don't know the time, right? We don't know. But we know that the height at that point will be at 0. So let's go ahead and plug in 0 for the height. I'll say height is 0. So if we have, 0 equals negative 16t squared plus 64t plus 80. Now we'll factor this. Again, 16 goes into all three of these, so I'm going to take that out as a GCF. Divide each one by 16. So we would have t squared, it's going to change these to all negatives now, minus 4t, and then divide 80 divided by 16. We have minus 5. So we'll keep the negative 16 here, and we can factor this. This is shortcut. We'll multiply as negative 5 and adds negative 4. That's got to be 5 and 1. We would have negative 5, a positive 1. Right, that should give you negative 5 when you multiply and add negative 4. Now we have three things being multiplied together. The negative 16 is not going to matter. It doesn't have a variable in it. We got to go ahead and split these up. We have t equals 5 seconds, or t equals -1. So clearly -1 is not going to work. Where does that 0 come from? This is coming from the fact that if you were to extend this line here, it would be at 0 at -1 seconds, which doesn't make sense realistically because just because the rocket started up on a platform. But then after that, if we start the timer and it goes up, it's going to come down. So this is kind of like our y-axis here. The time over here was at -1, and then over here on our x-axis, it comes down and hits at 5 seconds. So our answer is 5 seconds, not -1. We don't need that one. And that is enough to finish this lesson. We did both word problems, and there are 2 word problems for you to finish as well. And that will be the end of 6.7.